Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about what it means for a function to be differentiable. So we've talked about derivatives, and basically with a differentiable function, we want to be able to take a derivative of that function. Like the derivative has to exist. It's a lot like continuity. There's different types of reasons the derivative can't exist. So if it's not continuous, a discontinuity will make it not differentiable. Also, a sharp corner or cusp in the graph. So if the graph goes down like that and then it suddenly goes back up at a single point, there's no smooth curve, it just is a sharp corner. And the third reason could be a vertical tangent line. And you can think of this like a more advanced version of an eagle being able to fly along the graph. Because in reality, an eagle couldn't fly infinitely fast or instantaneously change direction in midair. And let's practice identifying differentiable functions. So we want to know which types of these graphs are going to be differentiable. So with one, they're just going down and then up. It's a smooth curve. So that's going to be differentiable. Two, that's a cusp, a sharp corner. It's not differentiable. It just changes direction instantly. No smooth transition of the derivative. And on three, it's a wave sort of thing that's going to be differentiable. Four, that's a sharp corner, so it's not going to be differentiable. Five, it's just going up. It's going to be differentiable. And finally, six, it's going down and then up, but there's a sharp corner. So that's not going to be differentiable. Only 5, 3, and 1 are differentiable. So now we're going to try a more complicated practice problem. So Jackie is flying on the function j of x equals 4 plus x minus 0.2 x squared from x equals 0 to x equals 5. Now Shadow is going to fly with some function s of x after x equals 5. Which one of these possible functions of s of x will allow Jackie and Shadow's flights put together to form a differentiable function? So basically what's going to happen is we're going to form a piecewise function. Jackie's going to fly to here, and then Shadow's going to pick up where she left off. And we want to find a function that Shadow can fly on to create a differentiable flight. Now, remember, for it to be differentiable, we need it to be continuous, so no jumps. And also we need the derivative from the left and the right to match as we get closer to 5. So we're going to start by taking a derivative of Jackie's flight. We have this function right here, and we're just going to do our normal thing to take the derivative. We have our expression right here. And the first thing we're going to do, as always, is cancel out these constants and subtracting them. Then we're going to expand out this x plus h squared, like that. And then we're going to distribute out the 0.2. And we're going to take all this stuff out of the parentheses because we don't really need the parentheses anymore. Now we can combine like terms, and we're left with this. So now we can divide by h, and we're left with this. Now h is going to go to 0, so we can just get rid of this. And we have our derivative, j prime of x equals 1 minus 0.4x. Now let's think about which one of these functions down here Shadow could fly on, so that when he picks up where Jackie leaves off, he can fly without there being any discontinuity, without any jump, or without a sharp corner. First, let's find j of 5. So that's going to be 4 plus 5 minus 0.25 squared. That's 0.2 times 25. That's going to expand out to 5. So we have j of 5 equals 4. Now j prime of 5, That's going to be 1 minus 0.4 times 5 equals -1. Now, for this function to be differentiable, we need shadow to have a y position of 4 and a derivative of -1 at x equals 5. So let's start with this. So our first option is x minus 1. Now, 5 minus 1 is 4, so it's going to match up with j of 5. But we can see that the derivative, since this is a linear function, the derivative is just going to be this linear slope. So that's going to be 1. And we need the derivative to be -1. Now, 0.5 x squared minus 2. Let's plug in the numbers for this. 0.5 times 5 squared, that's 12.5. Minus 2 is 10.5. That's obviously not going to work. Sine of pi x plus 2. Sine of pi times 5. Well, anything times pi, if you take the sine of it, you get 0. So 0 plus 2 is 2. It needs to be 4. So that's a discontinuity. That one doesn't work. And that leaves us with this final option, 0.2 x squared minus 3x plus 14. And we've already ruled out all the other answer choices, so I'm not going to actually take the derivative of this. You can try taking the derivative on your own to practice, but you can see that if I turn on the lines for this function, it does in fact have the same derivative. And if this is Jackie's flight right here and Shadow's flight right here, it's going to be a perfectly smooth transition. No jumps or discontinuities, no sharp corners. So that's it for today, and I'll see you next time.